Hi everyone. I see it's already 3 o'clock. So let's start with the intro, and I guess people that are a bit late will join in the process. So hi once again. My name is Julius, and I'm the founder and CEO of CloudWiser that is hosting today's webinar. And we also have Laimonas here, who will be delivering the workshop. Laimonas, you want to say hi to the audience?
Yes, hello everyone.
I'm very happy to see all of you joining this event, and then I see very good attendance rates, and then a lot of people registered. So hopefully you'll find this all of this content interesting and useful. And before we begin, just let me say a few words about CloudWiser and what we do for those who haven't heard of us before. So CloudWiser is an advanced tier AWS partner operating in Lithuania, Latvia, and Estonia. And we work closely with AWS to support the current and new AWS users in the region. And our main business line is AWS resell that is being used by a number of companies in the Baltics. So if your company is currently using AWS, I strongly suggest you check out the benefit packages that we offer that come as a bonus for your AWS spend that you already paid today. And next to that, we try to do a lot of things to build the local AWS community. And this workshop is a good illustration of that. Laimonas will be your today's speaker, and my role will be to support him along the way. So before passing the screen to him, I want to mention a couple of things regarding the workflow of today's event. So first of all, of course, your questions are very welcome, and please submit them in the Q&A section that you should see in the upper part of the Zoom window, and also the chat is fine for that as well. And we'll go through them at the end of the workshop, or maybe we'll have some time slots during the demo, so maybe we'll grab 1 or 2 questions there as well. The event is being recorded, so we will share it with everyone most probably tomorrow, so you have that in mind. And last but not least, Laimonas asked me to do a small poll around the audience to understand what level of experience we have here. So let me launch the poll. You should see it in the windows. So just please choose the level of experience that is that reflects your situation, and it's very important for Laimonas to see what type of audience we have, because as you most probably saw, this is a 300 level advanced workshop. So some serious and deep stuff will be discussed. So it's important for Laimonas to know, maybe should he explain some of the parts more just in more detail.
Okay. Yes, indeed.
Okay, I'm ending the poll. Frankly, I'm even interested myself to see how it goes. Oh. Okay.
Interesting.
We have quite a few with few or zero experience. So Laimonas, I guess let's try to reflect to the whole audience, if that's possible. I don't know if it is.
Yes, I will do that.
Great. So then that's all from my side. So Laimonas, are you ready to take over?
Yes, I'm ready to take over, and please let me share the screen. Please let me know when you see it.
I can see it, so most probably the rest of the audience as well. Just a small notice, we have more than 50 people already joined, so
awesome. That's very good. Yeah. Okay, so let us start then. Hello, everyone. Thank you for joining the session. I see that quite a lot of people have joined this session, which makes me really happy. I hope this is because of today's very interesting topic, which is testing cloud native infrastructure. And we are going to talk about both creating a cloud native infrastructure and testing it. So let's start from a little bit of introduction. So I am Laimonas Sutkus. Currently, I work in a company named Biomapas. I have, well, I would say quite a lot of programming and AWS infrastructure experience. Also, these days I'm quite active on GitHub, making my own repositories related to AWS, but also I'm doing some contributions to Biomapas and Identify open source projects, which you can check out in these links below. So my current company, Biomapas, is a service provider to a life science industry. It has presence all around the world and has nearly 20 years of experience in this industry. And one interesting fact that there is roughly 30% of employees that are medical doctors. And Biomapas has quite a lot of services to offer, ranging from clinical trials to regulatory affairs and pharmacovigilance. However, most importantly for me, as a technician guy, Biomapas is making medical services more digital. And I think the best way to go digital is to work with Amazon Web Services. And from AWS, we use lots and lots of services. So for example, from Dynamo databases for high performance real-time applications, to event bridges for decoupling our microservices architecture. So our applications are completely cloud-based with an aim for a completely serverless architecture. And as for the last slide of introduction, I wanted to mention that we are hiring developers. So if you are an Angular developer or AWS DevOps developer or a Python developer, please do write me. My email is laimonas.sutkus@biomapas.com. We are looking from junior to senior positions. Okay, and now let's talk the real business, testing cloud native infrastructure. And let's get over the terminology really quickly. So testing, well, in very simple words, it is ensuring that things work. Cloud native means that the application can run only in cloud and not on your computer, for example. And the term infrastructure, well, I would say you can think of it as a group of cloud components. So today we are talking about ensuring that a group of cloud resources are working as expected. And I'm pretty sure that most of us are familiar with words like testing and infrastructure. However, I want to underline the term cloud native. And cloud native architecture is the design for applications and services built specifically to exist in the cloud. And there you can see a graphical representation of such architecture. We have separate managed components like S3 buckets, Lambda functions, SNS and SPS topics, Redshift, QuickSight, and so on. And these separate components talk to each other to create business logic. Cloud native benefits include a more efficient application development process, a more moldable application architecture, and a more adaptable application infrastructure. In other terms, it is easier to develop and deploy, it is easier to scale, and it is definitely easier to maintain. And I want to point out that you get these benefits, again, only if you do it right. And even then, there is an overhead of complexity, resulting in more complex configurations, harder to find bugs, performance issues, monolithic dependencies, and as today's topic suggests, harder test scenarios and more complex automated tests. So how can we make cloud native less painful? Well, throughout the years, what I found extremely useful is to firstly define your infrastructure as code, and secondly, break down that code into smaller separate packages. And what is infrastructure as code, you may ask? Well, it is a process of managing and provisioning your infrastructure through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools like AWS console, for example. Here you see an illustration where we have a JSON document that is being read by some tool, and then that tool creates an infrastructure accordingly. And that tool in AWS ecosystem is called CloudFormation. As an input, it takes JSON or YAML templates, reads them, and provisions AWS infrastructure accordingly. However, JSON or YAML templates are, I would say, notoriously horrible to manage. They are not really human readable. It is hard to define resources. There are no for loops, if statements, or structures like in normal programming languages. And those templates are quite hard to test. Thankfully, AWS realized that, and a few years ago, they released an AWS CDK, a cloud development kit, which lets you write in Python, TypeScript, Java, or C# code to define your infrastructure. And what this kit does, it translates your program into previously mentioned JSON or YAML templates. It sends them to CloudFormation directly. And frankly, you never have to deal with those templates yourself. AWS CDK completely deals with them. And this is a code snippet of how an AWS CDK infrastructure program looks like. We have a class which represents a CloudFormation stack because it inherits from core.stack. And inside that class, we have created some resources. So for example, we have created another stack and a stack output. Nothing fancy, but this is like the main idea. However, this is where the actual beauty begins. We can have, for example, conditions, as one provided here that is named some example condition equals 2 less than 1. Well, it's a stupid condition, but it illustrates the fact that, well, indeed, you can use them in your infrastructure as code templates. Also, we can have for loops. And as you see in this example, we have a for loop, and inside that for loop, we have a condition. And in that condition, we are creating Lambda functions. So since the condition always results in true, we should create 2 Lambda functions with this example. And if we were to execute this infrastructure as code program, this is what we would see in the CloudFormation service. It has created a stack and some Lambda functions. And indeed, we can find those Lambda functions if we navigate to a Lambda service. So in total, our CDK program has created 2 Lambda function resources, as we have specified that in our for loop. If you have a question of why those Lambda function names are so ugly, well, it is because we haven't specified the actual name for the functions. We have specified just the ID. Hence, the CDK application used the resource ID that we have specified as a name. And those random strings that were appended as a suffix to the ID is framework's attempt to avoid possible ID clashes. It's quite an ugly solution, but I'm happy that at least it works. So in any case, we can specify Lambda function names, and we can have beautiful resource names, not like in this example. All right, back to our original topic of today's presentation. How do we actually test such an infrastructure, and how do we write tests for it? This is an example test which invokes one of the Lambda functions and asserts that response of those functions is as expected. So for example, in the first 3 lines of the test, we are creating a Boto3 session. For those who don't know what Boto3 is, it is basically a Python SDK for AWS API. So instead of sending those HTTP requests, you simply create an instance of Boto session, and you invoke various commands through the SDK. So we create the session, and in the next 3 lines, we create a client, and then we invoke an actual function. Then we parse the response, and we assert that the data is equal to, like in this example, hello from Lambda exclamation mark. So this is like a very simple and an obvious test. But this type of testing has 2 major drawbacks. And the first one is that we need an already deployed infrastructure to be able to run those tests. And secondly, we need to hard code names or IDs of resources that we test. Imagine if we had to redeploy the infrastructure, we would have to go through the tests and update those IDs or names. So as in the previous example, you see here that we specified the function name here. And if we were to redeploy that function, this suffix would change. Okay, so ideally, what we want to achieve is this sequence. So we firstly want to deploy a fresh and independent infrastructure dedicated just for our current test session. Then we dynamically reference resource names and IDs in our tests. We run those actual tests. And lastly, we destroy the infrastructure back as nothing ever happened. And to achieve this with a great convenience, Biomapas IT team has developed an AWS CDK-based infrastructure testing framework. It is a super lightweight framework. It just helps you to do some basic logic functions. It is based on PyTest Python testing library. And I think most importantly, it is an open source project, so anyone can start using it now. And now, this testing scenario where you create and destroy infrastructure per testing sessions only makes sense if you follow my second advice. And it is to divide infrastructure as code package into many small ones. So there is a sample graph where every blue square represents a package that defines some part of your whole infrastructure. So instead of having one really big blue square that defines your whole infrastructure, you should have many small ones with their own tests, their own pipelines, and their own versions. So you can think of it as a microservices architecture versus monolithic architecture for services, right? But this is not for services. This is for infrastructure packages. And with all that said, I think we can start the demo part. And I want to mention the demo and other material is prepared with Python programming language. I'm mentioning this because we're going to see quite a lot of Python. But for those who are not very familiar with this language, don't worry, we are not making anything super fancy. So it should be still easy to follow this demonstration. And for the demo session agenda, I would like to mention just a few steps what we're going to do. So our first big milestone is to create an infrastructure project. Firstly, we're going to install the CLI tool. We're going to initialize the project, create some resources, deploy them, and then we will go a little bit more advanced. We're going to create a cloud-native serverless REST API using API Gateway service, and every endpoint of that gateway should be backed by a separate Lambda function. Then another milestone is to deploy the actual project and ensure that everything works. The third, and I think the most important one, is we're going to write integration tests. Firstly, we're going to do it the bad way, where we already need the deployed infrastructure in order for tests to work. And then we're going to install AWS testing framework and refactor those tests to use a previously mentioned ideal scenario of create, test, destroy. And lastly, we are putting everything in a CI/CD pipeline. And for that, we're going to create a sample GitHub repository. We're going to commit and push the project there. And for the CI/CD part, we will simply use GitHub Actions to achieve that. And we're going to then run the pipeline itself and see whether the pipeline succeeds and whether everything works as expected. Okay, so I'm ending the presentation for now. Let's firstly open the terminal and ensure that we have all tools available for us. So as mentioned in emails from CloudVisor, we need Python for that. So let's check whether we have Python. We should use, well, preferably the third one. Okay, we have this one installed. What else? Well, the CDK tool is written in JavaScript, as I believe, or TypeScript. But in any case, we need Node and npm to install that tool. So let's check whether we have Node and npm. Yep, so we have these versions also. I think I might have like one of the latest ones, but if you have like Node version 12 or npm version 6, these are more common ones, I think. You can use them also, and I think everything should work just fine. And yeah, so the main tool that we should have is the CDK -- version. And to uninstall or install the CDK, so let me first let's say to uninstall it. Let's uninstall. I think it's like this. Not sure if that's the right command. Okay, it was the right command. So to install the AWS CDK package, you simply run npm install globally AWS CDK. And it should install it. And once it is installed, let's ensure that everything works as expected. Okay, so since we have all the tools available for us, we can start on creating the project. Let's go, for example, to the desktop and create a directory. How we want to name it? Let's say we want to name it CloudVisor. Okay, and let's go to the CloudVisor directory. So to initiate the project, you simply run CDK init. And it tells you what languages are available. And it tells you that you should specify the language in which you want to write the infrastructure as code project. So as I mentioned, there is like C# and Java, but actually there are more like F# and TypeScript. But for today's presentation, as I mentioned, we have prepared everything in Python, so we will use the Python programming language. So again, CDK init -- language equals to Python. And now it's doing its own stuff, creating some files, initializing Git repository and other similar things. So let's see what it created. Well, it created quite a lot of files. These Git files, I think everyone is aware of them, what they do. The virtual environment is a Python specific thing, creating like an isolated environment for just this specific project. We have README file, we have requirements. Setup.py file is again Python specific for creating packages. But what is not Python specific and what is CDK specific is these two files. It is app.py and cdk.json. And let me open this project in PyCharm IDE. So it would be easier to follow me, and the presentation would be more visual. So let us open these two files. So let's start from the app.py. And this is basically an entry point for your infrastructure program. This code was generated automatically for us, and it tells us that well, we need to create a CDK application. We need to attach a stack to that application, and then we need to synthesize it. Very simple. And the CDK JSON is a configuration file. For today's demo, we are not touching it. It is as good as it is now. So let's get back to our main entry point, and we see that we have some dependencies missing. But if we were to open the setup.py file, we see that there is a requirement specified that we need to install AWS CDK core. And well, frankly, we can simply install it via command line. But firstly, let me quickly check out the virtual environment. So again, this is Python specific thing, not the CDK specific thing. And to install all dependencies, we're simply running pip install recursively everything that is specified in the requirements file. And in the requirements file, it said install everything that it is in the same directory. And it is well, basically going to install all the dependencies that are specified here. Well, here we're again talking a little bit more about the Python stuff, but we will soon continue on the CDK part. So let's install the dependencies. It shouldn't take much time. Okay. And I think the PyCharm is not very intelligent IDE, and it can't automatically see the environment. So let me simply specify it very quickly. Virtual environment, bin, Python, okay, okay, apply, okay. And let's open this one. Okay, so everything was indexed, and now we can walk through the source code of the CDK package. Okay, so we have installed, well, firstly, we have created the project. We have installed all the required dependencies. And now let's start talking about stacks. So here we have a predefined CloudVisor stack, and it sits right here. And well, as the comment suggests, this is where we define our resources. So for example, we can create a previously mentioned stack output. And to do that, you simply tell that you want to create an output. And now, for the parameters, you always, it doesn't matter which resource you are creating, you always have to specify the first two. It is the scope and the ID. The scope, well, it basically tells in which CloudFormation stack this resource is going to belong. So for the scope part, it is going to belong to this stack. So we simply say self. And for ID, well, for ID, you can get creative. Let's say my cool output. Now, if we were to go to see what else is required, well, the value is required. You can also specify the condition, the description, and export name. So let me specify the export name and the value. Export name is my cool, I know, name. And for the value part, let's specify this is the value. Okay, so we have created one resource. It doesn't do much, but it should be enough for us to now deploy it. And in order to deploy this infrastructure as code application, you would simply write CDK deploy everything. But before we do that, some of you got the credentials to follow this tutorial. Let's say so. So let's make sure that we have our AWS CLI configured properly. So firstly, let's ensure that we have AWS CLI installed. Yes, indeed we do. And now to specify the credentials for that CLI, which are also needed for the CDK tool, is you simply write AWS, I think it's called configure. Yep, yeah, it's called AWS configure. And as you can see, I have already specified my default values. So access key ID, access secret key, the default region, which for example is central 1. And the default output format can be anything. Again, I think most of you that used the AWS resources have installed this AWS CLI in your machines. This is one of the most essential tools when working with AWS, actually. Okay, so again, for those who got the credentials, you should simply initiate the AWS configure command. And when it asks you to write the access key ID, you should specify the given one. And for the secret access key, again, the given secret. And once that is done, we can try and see whether our configuration actually can connect to AWS. So the easiest command that you can do is you can try to list all S3 buckets. So AWS S3 LS, it's called for list. And you can see that indeed our credentials are working, and we were able to retrieve all of the S3 buckets.
Laimonas?
Yes.
I saw a question from Simon in the chat. Like, is there a config file somewhere, like something ready to go? I don't think we have something like that. We're creating that on the fly.
Yes, we are. Yeah. So for the project, we are configuring everything on the fly. However, I was preparing for this demonstration, and I tried to do everything before this presentation, and I was ensuring that everything is going to work. So there is the example repository. So if you were to go to GitHub and paste this one, okay, I will just quickly paste this.
Yeah, maybe in the chat.
Yeah, I'm opening the chat. Okay, great. To all panelists and attendees. So here we have an example repository. Yeah, you're welcome. And well, it was created with basically with the same steps that we are doing now, but now we're doing everything on the fly. Okay, so I think we should continue now. And as I mentioned, that when we have everything configured successfully, now we can initiate the deployment command. And to initiate the command, we simply write CDK deploy and the asterisk mark. We should quote the asterisk mark, because in Linux-based systems, it will try to expand the asterisk mark and try to input every file in the directory as the input command. So we should quote it. And for Windows, I think it's not necessary, but for Linux-based systems, it definitely is. So CDK deploy and quoted mark asterisk, and let's hope everything works. And I think indeed it does. It says deploying, and it's creating CloudFormation change set. And it should be very quick, because we have one very, very small resource, and it's done. And for the outputs, again, as you can see, we have my cool output equal to this is the value. But I think more interesting part is to actually go to, one second, is to go to the service itself through the console and see visually what was done there. Give me 1 second. I will try to find the credentials. Okay, I think these are the ones, right? Okay. Okay, so I have logged into the same account that I was deploying for, and let's write CloudFormation. And as we see, we have 2 stacks. So the first stack, called CDK Toolkit, well, it is being created by default by CDK tool itself. Basically, you simply shouldn't touch this this stack. And the stack that we are actually interested is that was recently deployed, the CloudVisor stack. And we gave it the name CloudVisor. Let's open the stack. Let's go to the events. Some of these were, again, CDK specific things, CDK specific actions. However, again, the most interesting resource that we have created is in the output section. And here we see that we have my cool output, and this is the value. All right. I think we have successfully, again, created the project, created some resources, and deployed it. Let's do something more fun, or let's say more useful. And let's create a Lambda function this way. So how do we do that? Well, firstly, we need additional dependencies for this project. Here it says there is only one dependency to the core library. However, there is one more that we need to specify, and it is AWS Lambda. Yeah, I think this is how it's spelled. Let's try to install it. Okay, as I see no errors, it is done. Now, how do I know that I need to specify AWS-Lambda instead of just Lambda or anything else? Well, all of these packages are actually published in PyPy, Python package index. For other languages, I'm not sure. It should be like npm or NuGet repositories, but for Python, it is definitely PyPy. And if we go to Py, and if we were to write something like AWS Lambda, come on. PyPy is down for maintenance or is having an outage. Very nice. Anyways, all of the packages like AWS Lambda, AWS API Gateway, S3 buckets, SNS SQS topics, and frankly, for every single service that exists in AWS, there is a separate AWS CDK package for it. Let's try to refresh it, and let's see if it does any good. No, most likely not. Okay. Anyways, we can continue. So we have installed the dependency. Let's go back to the stack. And now in the imports section, we can simply write from AWS CDK dot AWS Lambda import function. It is as simple as one line of code to import the function. And now we need to create one. So let's simply tell that function. And as I have previously mentioned, these are always two first parameters that you need to specify, the scope and the ID. And there are a bunch of more parameters that you can specify, like log retention and profiling group and other fancy stuff. But for today's demo, we're keeping it simple, and we want to just simply create a bare bones Lambda function. So let's do that. For the scope, again, we're telling that this is the CloudFormation stack. For the ID part, again, let's say my fancy Lambda. And now, as you remember, I told you that if you just specify the ID of the resource and it can have a name, the CDK will take that ID as a name also. But those IDs can become pretty ugly. That is why there is another parameter that we can pass to, is the function name. And frankly, we can say that it is the same, my fancy Lambda. As you create more and more of these resources, you will start developing some of the patterns yourself. And one pattern that I have developed myself is I usually pass just the, let's say, just the construct. So this guy, usually, and all other things like the stack name and other thing and other properties should be configured by this stack, by the class itself. So what I like to specify also is the prefix for our components. So if we were to have multiple infrastructures in the same account, well, at least we can separate them with the prefix, and one prefix means one, let's say, one infrastructure, another one separates another one. So these are two parameters that I usually use in the stack constructor. And here we can think of it, let's say stack name is, again, the cloud visor. But since now we're using the prefix, well, let's use the prefix. And let's specify the stack name. And there is also, again, a parameter called stack name, which is going to modify the actual name of our stack, just the same way we have these parameters in our Lambda function. And for the prefixes, again, I will do the very same thing with my other resources. And well, for some of you, it might make no sense to have these prefixes if you decide to have one infrastructure per account. However, these names do play a significant role if we are testing if we are writing automated tests for our infrastructure, because we might have multiple pipelines running in parallel. And if we have multiple testing pipelines running in parallel, inherently we're going to have more than one infrastructure in that account. So we definitely don't want these infrastructures to interfere with each other and to clash. And one way of controlling this is with prefixes. So this is the pattern, for example, that we have developed in our company. Let's continue on creating the function. There are quite some other parameters that we need to provide. It is code, handler, and runtime. Let's define the code part. For the code, we are importing the code library, and we're saying that we're going to specify in this project itself. So for the function, let's say define handler. It will take any amount of args and named arguments. And it will simply return hello from Lambda function. Okay. The other thing we need to specify is the runtime. And for the runtime, again, we are importing another class, which is enum. And we are going to specify Python 3.6. However, we can even specify 3.8, I think, yeah. But for today's demo, we're specifying 3.6 because with higher versions like 3.7 or 3.8 or 3.9, you can no longer define your code from inline. You need to have a separate asset. So as today we want to make things simple, we are going to have a code as an inline. And I think there is one more parameter to specify, and it is the handler. And the handler for Lambda functions is basically the path where the Lambda service should call when it's being invoked. And the handler in this scenario is going to be index.handler. And what does it mean? Well, since we are defining our code like an inline, the CDK is going to create a default file for us. And the name of that default file is index.py, hence index. The handler part is the name of the function to invoke, hence handler. And that's the full path, file name and the function name, index.handler. I hope it makes sense. And I think that's it. This is simply a few lines of code to define our Lambda function. I hope we're not missing anything. And let us try to deploy and see what happens. Okay, now it asks me that I'm creating a new resource. The resource is Lambda function, and for that Lambda function, the CDK is attaching AWS Lambda basic execution role. And when every time there are some role permission changes, the CDK will ask you, are you sure these are the changes you intended to do? And if you're sure that these are the correct changes, you simply press yes, and you continue the deployment. Okay, so my cool name is already exported. So since we have renamed our stack from CloudVisor to Prefix, and I think this is where we did, let's say, we didn't think about the prefix part till the end. So now we should have CloudVisor. Let's see if that is true. But also what we need to do is to add prefixes also here. So prefix, I think export name should be fine, and this is the value. Again, I hope it should be fine. Let's see if those names do clash or they don't. Okay, it's creating the change set. Okay, so it still complains. Let's go back to the our original CloudFormation service, and let's simply delete those both stacks that are causing us the headache. There are two ways how we can delete those stacks. One is, well, the one that I just showed you now is through the console. And another one is through the CDK tool. You simply, instead of deploy, you write CDK destroy. And again, you can specify either specific stacks or the asterisk mark to destroy everything. Let's refresh. We see now all of those tool stacks are destroyed, so we shouldn't have any more problems. So let's initiate the deployment again. Okay, and we see that the create is in progress. And if we were to refresh it, we see that indeed the CloudVisor, this is a stupid prefix. We should have named it like dev or prod. Well, it doesn't matter. You get the idea. And let's go to the events part, and you see that now it's being initialized. The CloudFormation service is a little bit slow to start, but when it starts spinning, it should create those resources really fast. So let us refresh the events table, and we see that there are roles that being created. And well, as you can see, it has finished. Let's refresh again, and we see that Lambda functions are also finished. One cool thing about the CDK is that it can hide some of the configuration from you if you don't need to specify it. For example, we did not want to specify the Lambda role. However, when you're creating a Lambda role, you always need to specify, when you're creating the Lambda function, you always need to specify the role for it. But in this case, CDK was smart enough to say, okay, you did not specify the role, so I'll assume that you want to attach a default one. And let's go to the Lambda service. And indeed, we see the CloudVisor My Fancy Lambda. This is the prefix part. And if we were to open it, we should see the, as I told you, index.py file. And here we have the handler function that simply returns hello from Lambda. We can definitely test it. Let's say the event name is test. Let's simply test it. And we see that the response is hello from Lambda. So everything works as expected. Let's get back to our project, and I want to show you one thing. So for example, what happens if you delete the resource? Well, if you delete the resource, the CDK still sends this, the new JSON or YAML template to the CloudFormation service. And the CloudFormation service is smart enough to detect the change set. For example, the change is the deletion of the output. And the CloudFormation will initiate that delete action. And again, if you were to deploy this change, I should go back to the outputs part, and we see that it's still there. But after the deployment finishes, again, it shouldn't be there anymore. So let's wait for a couple of seconds more. Okay, so the update is complete. The same is being told in our terminal. So we no longer have this resource. Now we can continue on building what we firstly intended to build, and it is cloud native serverless REST API backed by serverless Lambda functions. And for that, well, we need, again, another dependency, because now we're going to use the API gateway, service. Let's see if the PyPy is back. Awesome, it is back. Okay, so the other package that we are going to use is, I believe it's called API Gateway. Okay, yep. So we're going to use the API Gateway library. And what's cool about every library that it has its own documentation, and you can simply read the documentation, read the examples, and get a grasp of what is going on and how you should create those APIs. And in this example, the example is very simple. You create the API in simply one line of code. Let's do that. Let's create an API. Firstly, we need to import this API gateway. But again, I don't have that dependency. So simply, let's copy the name of that new library that we are going to use and specify in our install requires definition section. And again, let's install it. It couldn't find the requirement, I think, because it's 7.4. Okay. Let's try to specify one less. Oh, my bad. So stupid. Sometimes these mistakes happen. I just blindly copied the name, and I didn't see that there is a duplicate. So let's go back to the original version. And, everything should work as intended. All right, we have installed the dependency. Let's uncomment our code and let's now try to import it. I'm not sure if the ID, the PyCharm ID, has already indexed all those parameters, but we can simply try to from AWS CDK, AWS API Gateway. We can try to import. Now we can import the REST API. However, the more cool part is to import Lambda REST API, which by default already tells you that it has some already pre-configured configuration to support Lambda functions out of the box. So we won't need to specify anything fancy. So let's do that. Let's try and import Lambda REST API instead of an ordinary REST API. And let's delete that function and rename it with another class definition. Again, these are the two parameters that you always have to specify: the scope and the ID. But there's something else that you actually need to specify, and it's the handler, the function that is going to handle the incoming requests. And this is the default Lambda function that will be triggered whenever you try to invoke the root endpoint of that API. So no, just for the path, it's just a slash indicating that it is the root path of the API resource. So let's simply specify that. How is it? Okay, it's called handler. So let's specify the handler. And the handler is going to be our Lambda function. So let's save the function and say that it is the function. For the API part, we can also expose it and make it available from the outside. So again, I think this is what we have to do to deploy it. Again, the other pattern that I like to follow and my team likes to follow is to have named parameters. So I'm just simply going to tell that it is scope and it is ID. I also would like to rename this API, as it makes no sense to call it Books API. And again, we need to specify the prefix. And let's say we have the example API. Let's try to deploy it and see what happens. Okay, so we again have another changes in our IAM service. This time we have even something called push to CloudWatch logs. So not just Lambda function can have logs. API gateway itself can have logs, and this specifies that it should be able to do that. So everything with these IAM modifications should be fine, and we should be fine to initiate the deployment. Let's go back to our console and see what is happening there. We already see that the update is indeed in progress. Also, we can open the API gateway service. And we already see that it has been created. If we were to go in, we see that sample paths, like the most root path, as I told you previously, was created. And the integration for that root path is our so-called this Lambda example function. The any means any HTTP request, so it can be post, put, batch, delete, get, you name it. Okay, so as we can see, it was perfectly deployed. I think it is the dashboard. Nope, not the dashboard. Documentation, also no. Models, no. Yeah, I think it's called stages. No, not even the stages. Somewhere is the, oh, okay. So there is the API endpoint that was created for us. But as we can see, also there is an endpoint in our outputs folder. Not the folder, but in our outputs section. So we can also find the output here. Now, question to anyone. I mean, question to everyone. Do you think it will work? And you don't have to answer it, or well, okay, fine. You can answer it in the chat. But the question is, if now I open this URL, will it work or not? What Julius thinks?
I trust you. I bet it will work.
Okay. Yes.
Okay.
Ignas Kizelevičius says message internal server. Exactly. Julius, we will get an error, and it was actually intentional. So if we were to open this, we get an internal server error. And this is a good gotcha for some pros out there. If well, if you were following me closely, you should have noticed that, okay, let me quickly close this one. You should have noticed that the response of this Lambda function is hello from Lambda function. However, this is not the right response for the API gateway service. And we can verify that by simply going to the AWS documentation and say, how do I write this? AWS API gateway Lambda response format. Okay. Okay, let's go for the proxy integration. And for the proxy integration, we should somewhere see what is the expected output of the function. I'm just quickly skipping through. Okay, this is the input, request context. Okay, so the output format of a Lambda function for proxy integration. You can't return simply a string. You need to return now a dictionary, and the dictionary should have some keys specified, like, is the response body base64 encoded? What is the status? What is the HTTP status? What are the headers of the response? And what are the multi-value headers? And lastly, the body itself. So let me quickly open the example that I was using previously, and some of you are using now. Because I'm too lazy to write this code, so I will simply copy it and close the project as nothing ever happened, and I'm going to paste it there. Yeah, when you are specifying the Lambda code from the inline, it can get pretty ugly pretty quickly. As you can see, you need to specify a lot of quotation marks, which are not very human readable. So better thing to do is to have not from the inline, but from asset. And if you specify from asset, then you need to specify the path to the directory where Lambda function source code is. And there you can, again, specify other languages like C# or JavaScript. And it should be way more convenient. But again, for today's presentation, we're going to use the inline. And this is what we're going to respond with. We're telling that our response is not base64 encoded. The response is successful. We don't need to pass any additional headers, and the body is hello from Lambda function. Now, what is cool about the CDK, that not just the CDK, but CloudFormation also, that it can detect the changes of the internal resource. For example, if we have modified the Lambda function source code, it will see that the function code was modified, and it will initiate the update action. So let us do that. So update is in progress. Where is our, okay, we should go back to our stack, refresh it. The update again is in progress. And it's done. Okay, it's done. So let us refresh the function and see how it looks like now. Oh, come on. Use remote. Fine, use remote. Okay, so again, this is what we have specified. Base64, no, it's not encoded. The status code is 200, and the body is a value hello from Lambda function. So now if we were to open this URL, everything should work, and indeed it does. It has returned the correct format, and then the API gateway service has understood that format, and it has returned the body to the requester. Okay, the first and the second milestones are completed. We have created a project. We have created an infrastructure with a cloud native serverless REST API. And now it's the testing part. How do we test it? Because if we were to use non-cloud native solutions, so if we were to use, let's say, web development frameworks like Django, Flask, or for other languages like Laravel, for example, for PHP, the tests would be very easy to write because the infrastructure runs on your computer. You simply run those tests. The HTTP requests are being handled internally, and everything works well. The process of testing is very straightforward. Everyone understands it. But now you have this web API that does not run on your system. It runs somewhere else. How do you write tests for this type of scenario? Okay, so let us start writing some tests. As I mentioned previously, let's start from the bad example. Let's create a separate test folder, which can be CloudVisor test. Yeah, of course, add everything, whatever. Let's create, sure, whatever. Let's create the test itself immediately. So there are two ways how we can write tests for this specific infrastructure. So one way, we can try to invoke the Lambda function itself directly and assert the response. And another, the better way, is to actually call the endpoint and assert the response of the endpoint, because in this type of scenario, you're not only testing the Lambda function, you're also testing the integration between Lambda function and the API gateway and the API gateway itself. So you're testing multiple components. But for today's demo presentation, I think it is not very interesting to have some HTTP call requests initiated and tested. I think everyone is familiar with those. What is more interesting, I think, it is to use the Python SDK Boto3 library to invoke the Lambda function directly and test its functionality. So let's do that. Let's test the Lambda function and not the API gateway, even though it would make more sense to test the endpoint. So let's do that. Test Lambda function. Let's create a function. Fine. And the scenario for the testing is as follows. Firstly, we need to create a Boto session. After we have created a Boto session, we need to create Lambda client. Then we need to invoke the function. Then we parse its response. And finally, we assert the response, that the response is as we have expected. So this is our plan, how we are testing it. So let us start. Let us start by importing a Boto library. However, we don't have that. And again, this is another dependency that we need to specify. And let's do that. Let's specify. It's actually called Boto 3. I'm not sure what is the latest version, so let's not specify anything. It will by default take the latest one. However, again, it is a bad practice. Please don't do that in production. In production, you should always use the exact dependency versions. So dependency was installed, and I think it's called Boto 3. Yeah, it's called Boto 3. So session equals Boto 3 session, and there is multiple ways how you can pass the credentials. You can pass AWS access key and AWS secret access key directly here in the constructor. Or you can simply pass the profile name and the region name. And you can do that if you have your AWS CLI set up. So back to the terminal. If you have done this, AWS configure. And if you have specified the name of that profile, then use that name. If you haven't specified it, it is called the default then. So let us do the more convenient way. So the profile name should be default. And the region that we are deploying to, or not deploying to, but we are trying to access is the central. The Europe Central, which means Frankfurt. So U Central 1. And I think that this is enough just to specify in order to create the session. Now let's create the client. And to create the client, we use the session and we create the client. And the client is going to be called Lambda. Now, again, how do I know what is the name of the client? Well, again, we simply go to the documentation. Boto 3 Lambda. Let's open it. And you see it says import Boto 3 and Boto 3 client Lambda. There is like one intermediate step. We're not directly calling the client. We are firstly making the session, and then we're only making the client, because only with the session we can specify the profile name. Okay, we have created the client. Now it's time to invoke the function. Client.invoke. As you can see, we don't have any suggestions what the available functions are. Hence, we need to go to the documentation part and look for the invocation function, which is this one. And in order to invoke the function, we need to provide two things, the function name and the invocation type. So let us do that. Let us do that. Function name. And I'm already lost. Invoke. Come on, where's the invoke part? And invocation type. For the invocation type, there are 3 types: the event, the request response, and the dry run. The event part is the asynchronous call, so it will call the function, but it will not wait for its response. The request response type is the synchronous call, and it will wait for its response. And the dry run is it won't make the actual call. So for this type of scenario, we need the synchronous call. Now the question is, what is the function name? Well, there are multiple ways how you can retrieve that. We can go to the stack. You can see that the name of the function is my fancy lambda plus the prefix. Or you can go here and copy it like that. But I hope that you are starting now to see, well, the problem with this test is that now we need like to hard code the name of the function, and it can become very, very quickly inconvenient if you try to rename your resources, as sometimes it makes sense to rename them as the new functionality appears in your infrastructure. So we have invoked it. Let's save the response. What is the response, you may ask? Well, again, we open the documentation, and this is the response: the status code, the error, log result, payload, and execution version. The only thing currently we are interested in is the payload. So let's parse the response. Payload equals to the response. Response is the dictionary object. We took the payload, and the payload is a streaming body. It is a little bit tricky to play with. So what I'm going to do is simply do the type hinting. So my PyCharm ID would know what to suggest as I'm typing. So payload dot, you see that there are some now functions available, like iter chunks or iter lines. So we're going to simply use iter lines, and we are going to put it in the for loop, and we want to iter all of the lines. So line for line in lines. You can say that we have extracted all of the lines. Now it makes sense to concatenate all of them together. So data join lines. One more thing, the payload iterates through bytes, not the strings. So we need to decode them to UTF-8, this part. And now what we should be left with is a simple hello from Lambda function string, which is this one. Okay. So we have the data part, and now let's assert the response. Let's do it like that. Let's firstly assert false to ensure that test fails, and let's print the data and see what is the response. Let's quickly call the function, test lambda function, and let's simply run the test. And you can see that the test has finished, and the it failed as we expected, and the response is base64 encoded false, status code, headers, body, and the response. So what we need to extract is the body part. In order to do that, we simply use the JSON library to load the dictionary and to extract the body value. So again, if we were to run it, now we see that we have a beautiful message, hello from Lambda function. And now we can assert that data is equal to whatever we have expected. And if we were to run this, we see that our first test has indeed succeeded. But writing these tests in this type of manner is really not the preferred way to do so. And first thing, we need a dedicated, let's say, a dedicated tool to run tests like PyTest. And we need to do something with this part as it is very ugly. And yes, and the third part, and a very, very important part, now we're using an actually deployed infrastructure, which can be development infrastructure or a production infrastructure. None of these infrastructures are ideal because we want our tests to be run in a completely isolated, non-impactable environment. And now, in order to do this, we are going to use the tool that our IT development team has prepared for us. And it's called the AWS Testing Framework, if I can spell it right. Okay, so we have this guy over here, which again has a nice documentation on how to use this framework, but we're not going to read it as I perfectly know how to use this this framework. Let us go back to the project and let us install the framework, which is of version 0.0.20. Let's install again the dependencies. Okay. Don't worry about this. This is not, it's not actually an error. It is rather a very explicit warning. And yeah, we will fix that after this presentation, because there is some mismatching between both of three libraries. The testing framework tells that the maximum possible version of the library can be 1.16, and we have currently 1.16.21. So this is like not a deal breaker for our demo as of now. Okay, so we have created the not created. We have installed the dependency. How do we actually use it? Well, one way to do it is to open the example of the example project and to see how it's done there. And there are, as you see, multiple entries. You can, with this AWS testing infrastructure framework, you can use the CDK tool, or you can use those, well, I would say ugly JSON or YAML templates if you want to deal with them yourself. But today we are doing the AWS CDK part, and let's open this one, and it says, well, this is the example in the example folder structure, how it should look like. So there are two directories, so one for your business logic and one for your testing that logic. And as you can see, we should have well, at least 4 or at least 3 things apparent in this directory. So the first one is the conftest.py file, and conftest.py file is a PyTest specific configuration file where you can configure the behavior of the PyTest tool. App.py I think all of you know that already. It is the entry point of the infrastructure program. And CDK.json, I think, again, you all already know that it is the configuration of the framework. And as like in this example, we have a test that tests something. So let's do that. Let's firstly create a conf test.py file. It's conf test. I think it's okay. And the documentation says that the inners of the conf test file should look something like this. And indeed, we can simply copy paste everything, and we see that there are no import errors. Everything works as expected. And there are two functions. I would say there are like two triggers. One is triggered before tests are run, and the other one is triggered after the tests are run. And this is where this beauty of creating and destroying infrastructure begins. Before running tests, we prepare the infrastructure. After running the tests, we destroy the infrastructure. Simple. And again, this whole process is being handled by the framework itself. You don't need to think about all the processes that are happening behind. You just need to focus on your tests. So as we have this this file defined, now we can go to the next one and have app.py and CDK.json files defined. Frankly, we have them defined here, app.py and CDK.json. And I want you to remember the slides where I told you about the blue squares. If you are going after this structure, those little blue squares, they shouldn't be executables. They should be rather libraries that are being imported in the executable library. So for example, you have a core library, which imports many other packages. And there is only one entry point, like one execution project, which does the deployment part. None of your other small projects, like those small blue squares, should initiate the deployment part. Hence, these two files are completely unnecessary for us, unless we're using the testing scenario. So imagine we simply delete them and we create them in our testing directory. I'm too lazy to do that, so I'm simply just dragging and dropping them. So we have, let's imagine, we have deleted them from here, as this is a library, not an actual deployment project. But if we are testing it, in any case, we need to deploy it. Again, we can simply copy and paste everything. And now, as you can see, instead of creating Cloud Visor stack, we are creating the testing stack that is being provided by the framework. And we will get back to it pretty soon. Let's just handle other tests. So for other files, I mean. So this is the CDK configuration file, which is kind of the same. We have an additional file, an additional line here, but it is, well, again, for running tests, it is not very important for us right now. And we have the actual test. We still need to do a few things. So let's go to the app, to the entry point. And now we can see that we are not initializing the Cloud Visor stack. So let's do that. Since this is a default stack provided by the testing framework, it should be always included in your testing scenarios. So let's save it, testing stack. And now it's totally up to you what you want to do in this free space. So what we want to do is to create the CloudVisor stack. And let's do that. Let's import the CloudVisor stack. And again, you need to provide the parent construct. And the parent construct can be two things: the CDK application itself or the other stack. And in our case, we want to say that our main stack belongs to the testing stack. And again, let's provide a prefix. The prefix can be prod, dev, or whatever. But this is where the multi-infrastructure, multi-pipeline part is. Do you remember that as I said, that it makes sense to have prefixes in order to control how, not control, but in order to have multiple pipelines, multiple infrastructures running at the same time? Well, if we specify it like this, like prod, well, the prefix is always static. And it is inherent that your infrastructures will eventually clash. What we want is a random prefix, but the prefix should be consistent enough for the framework to be able to create the infrastructure, test the infrastructure, and delete the infrastructure. So instead of creating a random string here, what we are going to use is we are going to call the testing stack and get the global prefix. So the global prefix is going to be already pre-configured for you. And well, essentially it is a random string, but it is a persistent random string, meaning that it will be available for whole your testing session. So let's specify the global prefix. Once we have specified the global prefix, we can go back now to the Lambda function and deal with another problem. Well, one obvious problem is we no longer need to call the test directly. And the other not so obvious problem is this guy. We want to dynamically reference the names of the resource, not to hard code them. And in order to do that, we first need to export that function name somewhere. And it makes sense to export the name of the function to the CloudFormation outputs section, which is here. And again, the testing framework makes it very convenient for you to do that. Let's go back to the entry point. And let's say that testing stack, add output. And now we want to add the name of the function. So let's say the key is function name. And the value, well, the value is stack.function.function name. So we are referring to this function. And now we have a dynamic reference, because this name, well, it's never going to change. We're completely fine with it. However, this one can change as many times as you want, and it will not impact our tests. Now, the only thing left to do is to is to reference the name of the function here. And to do that, I think there are a few ways to do that, but the one I remember is by using testing manager. No, not the testing manager. We need to use the same testing stack. Yep, we need to use the same testing stack. My bad. And now we have a static method of getting the output. And now the only thing we need to specify here is the key. And the key, well, it was specified here. We can simply move it like this. Okay, my bad. Is the function name. Again, if you don't like the way we specify these strings, yes, there is a better method. You can simply have constants defined here. For example, function name equals to function name, and now you can import that function name in every test of yours, and this way you can have even a more flexible testing structure. But again, for today's demo version, let's simply stick to bare strings. But yes, indeed, there are better ways of referencing those keys. Okay, so now let's reflect. We have installed the AWS testing framework. We have restructured our project to have app.py, cdk.json, conf-test.py, and the test itself. For the app entry point, we have again defined the CloudVisor stack, and we have made one output with the key function name. And now we have refactored our test, which now takes that function name key and gets the actual value for it, which is called, I don't remember, my fancy lambda. Yeah, my fancy lambda. And now for the prefix, we're going to see that it is indeed a random string. Okay, I think it should be enough. It should be enough for us to try the functionality. And now, in order to run these tests, you simply run the command pytest, and you specify the folder where tests are. So CloudVisor _test. Okay, and I remembered one more thing. So if we were to initiate this command, it would fail, and it would fail with a very it won't fail. Okay, let me quickly tell you why. And it is because I have already specified AWS access key and AWS secret key in my operating system environment. So the way this testing framework works is it takes those credentials from the environment, and once we will put everything in the pipeline, you will very clearly see how those credentials are being used, and then how those credentials are being added to the operating system. Okay, so as you can see now, our infrastructure is indeed being created, which is there, the random prefix. I think it is L, L, B, C, as L, and the Cloud Visor. Okay, the creation is complete. Okay, we have run one test, and as you can see now, it is being destroyed. Okay, you see now the delete is in progress. So let's give few more seconds for it to complete. Okay, so the whole testing session just completed successfully. We have run one test, which is this one. And we have run this test in a completely fresh, dedicated environment just for this test. Okay, I see that we are kind of running out of time. Now we are at, there is like 10 minutes left. And the question is for you guys, would you like to continue to the fourth milestone, which is putting everything in a CI/CD pipeline? Or should we go to the questions and answers session? What do you think? Because it will take roughly like 20 more minutes to complete this presentation. Well, and it's up to you whether we should continue or not.
We have a couple of people showing interest. Let's maybe wait a bit. Maybe during that time you would like to answer. I saw in the chat that like at the very beginning, a very classical question regarding what's the difference between CloudFormation and Terraform, and which you prefer, like what advantages you see, and so on.
Okay, so let's do it like that. Let's do the Q&A session, and let's answer all the questions that are available for us. And once those answers are answered, let's continue on our CI/CD pipeline. Okay. Mm-hmm. So yeah, so answering this question, what is the difference? Well, there are some differences. Let's say first one, the CloudFormation, the Terraform is the third-party solution, and the CloudFormation is a native one. So there's one difference. And again, the question is which you prefer, to use native tools or to use third-party tools. And there might be some policies in your company which prohibit the use of third-party tools, let's say like the Terraform, and you are forced to use the CloudFormation tool. So this is like the obvious one. The second difference is with Terraform, you are actually making API calls from your machine. So when you run Terraform apply or something like that, all the API calls are being fed to AWS API, and this is how the infrastructure is created with Terraform. And Terraform handles all the change set functionality and all the resource deletion creation functionality, like the whole logic. And the difference with the CloudFormation is you are not executing anything on your machine. You are just passing the template, and that template, as it's being read by the CloudFormation, is being executed. So let's say again, those API calls then are being called internally, not externally. So this is another difference. Now, again, as I remember, there was a question which one I would prefer, and which is like, let's say, which, well, I prefer the one which is more convenient to use. And if I had to choose between CloudFormation and Terraform, I would definitely go with Terraform, because with the Terraform, you're not dealing with those ugly CloudFormation templates, which are defined in YAML and JSON. However, if we use such tool as AWS CDK, I am all hands down for the CDK, because it is an amazing tool. I mean, I have fallen in love with this tool ever since I have discovered it, and I cannot stop using it. It is an amazing tool. It fixes so many problems that CloudFormation had, and it makes the deployment so convenient. And it is way better than, let's say, the Terraform itself, if you use the CDK tool. So did I answer it?
Yeah, like frankly, I was expecting that, knowing what big fan of CDK you are, and I mostly agree. But I would say, from my experience, like majority of infrastructure as code users on AWS, I would say they're using Terraform, unless it's like very like early stage and they're like doing very little. But I would agree that CDK is most probably like the next step, maybe even more advanced.
Indeed.
You know, after today's session, there will be more fans, and then you'll do your part of evangelizing it.
Yeah, let's hope so.
And there's also two more questions from Daniels who had to leave early. So first is, doesn't the code become spaghetti, like spaghetti, using SDK to maintain infrastructure as code? It can be an issue if using a larger multi-account environment and infrastructure. What's your I think you answered that a bit because he wants to compare it with Terraform.
Yeah. So well, let me firstly mention that we are using this CDK for one of our projects that is, well, really big, and we are using again multi-stage environment. So for the development, for the staging, and for the production, and the infrastructure itself is quite big. So yeah, I was presenting a little bit of how not to make this spaghetti, and it is an analogy to microservices, actually. So you're not making this one big giant project of the AWS CDK project, but you're making many small ones. And once you have many small ones, you can test them independently, you can version them independently, you can deploy them independently. Yeah, it's like an analogy to microservices, and it really doesn't become a spaghetti code, because you can even reuse the code. You can have small libraries doing very repetitive tasks, and you can reuse them. So no, it does not become spaghetti if you're doing it right. Even the microservices can become a spaghetti if you're not doing it right. But if you're doing it right, it is a miracle.
One more question. Daniel was using a serverless framework before to maintain the Lambda functions. And are there any points why use SDK to create Lambdas instead of the serverless framework? I don't know if you
have of course. I mean, this serverless application model or serverless, let's say, framework itself, they are not well, they are used just in the serverless part, so for the API, let's say, gateway part and the Lambda part. However, you cannot make other tools with these let's say, with these frameworks or these repositories. The CDK is a solution, let's say, to everything, from, let's say, Dynamo DBs to event bridges to step functions to all of the things. And yes, I agree that let's say again the serverless framework is an amazing tool, and you also define in something like infrastructure as code there. However, I would suggest not to mix multiple tools into one. So one part makes one part of your infrastructure, the other part makes the serverless part of your infrastructure. I don't think it makes really sense. However, from the business perspective, if you already have this type of solution, well, I would suggest to go on with it. But I believe that the cleanest way to do it is to use, let's say, the CDK itself to build from A to Z solution, including serverless and other services.
Okay, and then the last question before we get on to CI/CD part is from Raimond's C# versus Python and CDK. Any pros and cons?
Yeah, I think there is, like, functionally speaking, there is no difference, I believe. There shouldn't be any difference in any language, because they are all being updated, I think, almost at the same time. So there are no pros, there are no cons. It's whatever you prefer. We prefer using the Python version because our data scientists are using Python. Our Lambda functions, like the backends of the functions, are also written in Python. So Python absolutely dominates our environment. Hence, our infrastructure is also written in Python. It's just the preference. And also the framework itself is written in Python. So if you want to use the framework, well, you won't be if you're using the C#. You need to use the Python if you want to use the framework. And one more thing to mention, we have created many, let's say, many small packages regarding AWS CDK in Python that are open sourced in Biomapas GitHub page. And also from my previous company, Idenfy, in that company, we have also published some AWS CDK packages, like open sourced them. So you, I think after the demo, after this presentation, I will share the links with you in the Slack channel, like Baltic community channel. I think Julius has shared that channel with you guys, and you will be able to check those packages, as they solve a lot of problems that might arise. So there is another, let's say, benefit to use Python, because there are companies like Idenfy and Biomapas that are open sourcing many cool stuff, so you can use just out of the box. Yeah.
Great. So I guess we can go on to the last part. No more questions left.
Okay, awesome. So let's go to the last part. Let me quickly close that chat button. So where were we? We have completed the testing part, right? So the test was successful. One thing I didn't do, and I forgot to do as I was looking at this part, is that if we were to deploy this project into the CI/CD pipeline, which runs on a completely new Docker machine, and I mean Docker image, it won't have these things specified. I mean, it won't have AWS CLI configured. So we should use something that, again, the AWS testing framework is providing, has provided us, is the credentials class. So let's import it from the testing framework. And conveniently, there is a property called Boto session. So what it does, it kind of wraps the environment functionality, as I mentioned previously, and now it tries to read those environment variables from the operating system environment. So if we, for example, have specified in the environment the profile and the region, it would take those. And if we have specified the access key and secret access key, it would take those. So this is, again, you're getting a little bit more flexibility when using the credentials class that is being provided by the testing framework. And I believe if I were to execute it now, it should fail because of the God damn it, it still works. Awesome. Okay. It's usually it is a more usual scenario when it doesn't work, but even when it shouldn't work and it works, well, it's amazing then. Okay, anyways, we can continue on the CI/CD part. So what we should do now is create a new repository. So let's do that. Let's create a new repository. Let's call it CloudVisor. I will delete that repository soon after this presentation, so I won't get any copyright claims. Okay, so let's create the public version of it. Very simple. Let's copy this line. And the CDK has already initialized the empty Git repository for us. So the only thing we need is to execute this command. In other case, we should write git init, but we don't need as we already have it present. And we have some modified stuff over here. In the git ignore, we should also ignore the .env and .ide files, which are, again, sorry, which are not needed for us. And let's git add everything. And let's see what files do we have. So we have the setup file, the test, all the test files, and other things. Okay, so everything seems fine. So let's commit. Let's see, add business logic and git push origin master. Okay, so as you would expect, we haven't specified anything for our pipeline, so the pipeline won't be executed. We're just looking whether everything works and everything was committed. So we have the ignore files, the setup file. In the tests folder, we have the app.py, cdk.json, conf-test, and the test itself. So now we can move to the pipeline part. And in order to create a pipeline, the way GitHub handles it is by you specifying the .github folder. And in that .github folder, you need to create another folder, which is called workflows. And now in that folder, you create an actual definition for the pipeline. And I believe it is written in YAML. So let's, the name can be anything. So let's say it's pipeline.yaml. And again, because I'm quite lazy to write these pipelines myself, I will open the example project that I've been using lately, and I will again copy paste everything as nothing ever happened. And let's talk about the pipeline for a little bit. You see, it is super simple. It's just, well, if we were to, yep. So it's like just 30 lines of code. How beautiful is that? Anyways, let's talk about the pipeline and what these sections mean. So I think this is pretty obvious. You just simply define the name of the pipeline, just pipeline. You can specify some default configurations for the containers or the virtual machines to run. So for example, we are specifying that we are going to use the bash shell instead of sh, as it allows us to have a more beautiful bash code. However, this is completely unnecessary. This is just the preference that I have. Now, this part, by specifying on, is the triggers part. And here you specify the branches or the actions that should trigger this pipeline. So we have only one trigger, and that trigger is the master branch trigger. So once we push something to the pipeline, to the master branch, sorry, this pipeline should be triggered. And now the last part is jobs. So once we have triggered the pipeline, what things that pipeline should do. And it's being divided into separate, let's say, separate steps. And every separate steps runs on a fresh new virtual machine with a fresh new Docker container. So since we have only one step, one job, we will use only one virtual machine that runs one Docker container. So for the machine, we're using the Ubuntu operating system. And for the Docker container, we are using a custom-made Biomapas CI/CD full Docker container, which is again is open sourced, and you can find it on the Docker Hub. There are some like convenient tools, like the CDK is installed, the Python is installed, and other cool things and tools are there too. So we specify the image. And now we specify the actual steps, the actual actions to use. So the first action is to check out the latest commit, the latest changes. Then we are running the installation part. And the installation part includes updating the CDK, installing all Python dependencies, and listing those dependencies just for debugging reasons. After that, we have the testing step, and in the testing part, what we do is we specify the access key, the secret access key, and the fault region. So our credentials class could pick up. And once those three values are exported, now we can execute the PyTest. And this is not correct. This should be CloudVisor_test. So the name of the testing library. Okay. So I think this part might not be very clear because I haven't specified how we retrieve those values and how we save those values in the GitHub platform. So basically, this is the syntax to retrieve the secret value from GitHub secrets. And well, this is the ordinary Linux-based export syntax to set those variables globally in your operating system. So for example, in Linux Docker image. So how do we do this part? How do we set it? It is very simple. You go back to the project. You go to the settings part. You scroll down and you see the secrets part. And here you can specify those secrets that are specified here. So let us do that. So let's create a new repository secret. This is the secret name. And let me quickly extract the ID. How did cat AWS credentials? Okay, let me quickly drag. Sorry. Let me quickly drag that window out of the sharing screen to update the secrets, because, well, that's why they call secrets, so no one would know them. So just bear with me for a couple of more seconds. Okay, we can go back. So I have specified the AWS access key ID and AWS secret access key. And the last thing that I need to specify is the default region. Well, the default region is not an actual secret. So the default region is the Frankfurt, and the code name for Frankfurt is EU Central 1. Now we have added those secrets, and once the pipeline is run, it can extract those secrets from the GitHub repository and put them in the actual operating system environment. And once it's in the operating system environment, our testing framework can pick it up and use it for running tests. So again, I think everything is in place. Let's try to add everything and see what we have changed. Well, we haven't changed much. We have added just the pipeline file. So let's commit it. And let's push it to master. Now, if we are lucky, we should see the triggered action. And sometimes GitHub can be really slow when it comes to executing pipelines, especially when it is a new repository, but as you can see now, it was triggered. Let us open our first job, and now we can see everything in action, what is happening. In theory, I think everything should succeed. However, I have my doubts. Maybe we have missed something, but in the error part, well, I hope it should be pretty clear of what we should fix. But let us wait for the test step and see whether it fails or not. Okay, well, let's see whether it fails or not. Yep, it failed. Let's see, maybe we have missed something. Let's open this. Okay, And now we're facing with a very let's say a very interesting error, where it says that some of the classes, some of the Python resources cannot be imported. And it is let's go to our app.py file. Well, I think it is because my PyCharm ID is again not super smart, and it just assumed the CloudVisor stack being in this blue folder, which is I think configured as the sources root. We definitely need to provide the full name, which is CloudVisor stack import CloudVisor stack. So sometimes this PyCharm ID does this interesting stuff. But yeah, at least the error was easy to handle, and let's see whether it fixed the actual problem. I think this comment is no longer needed. So git add again everything, git commit fix imports, and git push origin master. Okay, so as I mentioned previously, on every push, you get a pipeline triggered. So we should go back to the actions, and we see now another pipeline instance was triggered. And again, we should wait a couple of minutes to reach the test running phase, and we will see whether it succeeds this time or not. Okay, so we're initializing the Docker container. So far, so good. Okay, now the ultimate part. What you're gonna do? Okay, you're going to work. So that was a little mistake previously by me, but as you can see, it was pretty simple to start using the testing framework. And now what we see, the infrastructure is being created. So if we would go back to our CloudFormation service console, and if we were to refresh it, we see that we have now a new one. So it is called TU or whatever. And yep, it is the same one. So we can see the creation of the infrastructure in action from here, and also from here. Okay, so it shouldn't take super long. Now talking about the cost of these pipelines. As you can see now, they are completely free to use for open source projects. I'm not sure if there is a limit for that. Maybe there is, but as much as we've been using GitHub pipelines in GitHub for Biomapas repositories. We didn't have to pay anything. So I think you start paying for those pipelines once you go private. But if you're open sourcing these things, I think it's fine. One thing I want you to mention is sometimes you get log outputs, and those outputs are hidden in the logs. So there is like this type of security in place. Okay, so as we can see, the tests have passed, the containers have stopped, and we have successfully run our pipeline. So I think we can stop here. As you can see, the pipeline was successfully completed. Now, every time you push something to it, it should run those tests, and everything should be convenient. So for the last words, for the last slide, there are 3 main practices to take out. So first, you should create your AWS infrastructure using AWS Cloud Development Kit. It is a massively powerful tool that makes DevOps job much easier. The second part, don't make one big infrastructure as code project. Divide it into small ones that are easy to test, easy to maintain, and easy to version. Think of this as an analogy to microservices. And definitely use automation as much as possible, because managing all these smaller packages is an overhead that you want to get rid of, again, as much as possible. Okay, so thank you, everyone. This is the end of my presentation. I hope it wasn't too long, and I hope it was interesting and informative. You got like new experiences, and then now you know what the CDK is. If you have any questions, you can ask me now, or you can contact me later via email.
Yeah, or
that's it.
On the Slack channel for the community, right?
Exactly, or on the Slack channel. Exactly.
Yeah. I see that at least in the chat and Q&A section, we don't have any more questions. So okay. I just want to wrap up with like a final thing from Laimonas and my side, like a small feedback poll, like basically just 2 clicks. It's very important, for us to understand what we did right and which parts were the most useful to you. I think my guess, Laimonas, you would like to see that as well.
Yeah, I would definitely like to see it.
Okay, so as the numbers are coming in and everybody's voting, I would like to use this opportunity to say big thanks to you, Laimonas. It's most probably the longest workshop we did this year, but definitely.
Sorry for that.
But the deepest one, and like 25 people, like more than half of the people stayed till the very end. That means there's like a lot of useful stuff there, and I really appreciate all the time you and effort you took you to prepare for this.
Yep.
Okay, I'm ending the poll. Most probably who wanted to, and I'm sharing that. So 100% took something.
Yeah, that's awesome.
And as expected, the demo part is the most useful, which is, I would say, very common for all of the workshops. It's reading and seeing 2 different things.
Yeah, that was the intention. I wanted the demo part to be as informative as possible and as complete as possible also. Yeah.
So I don't know, Laimonas, anything to add from your side to close things? Use CDK.
Yeah. Yeah, guys, use CDK. Actually, yeah, it's a very cool tool. But yeah, again, to take out, yeah, surely use the CDK. Try to use the packages provided by Biomapas and Identify. They are on GitHub, open source. You can check out them anytime. Again, if you have any questions, you can write me an email or write in the Slack channel, Baltics community. There are many cool and good developers there. And yeah, as I mentioned in the very beginning, if you're maybe interested in working with us, again, please write me and we might have a nice chat.
Yeah, for sure. I totally recommend Laimonas as a CTO. So okay, so then I guess that's it. Thank you everyone for your time, and we're really looking forward to seeing you in our CloudWise events. We have one coming up next week, more from the not the workshop side, but on the security for Trend Micro and what they have especially built for AWS. And that's it. Like until then, until the next event. Bye everyone.
Hey, thank you guys. Thank you for attending. Bye.